Okay, just to recap, a vector can be shown as a simple arrow. The direction of the arrow shows the direction of the vector, and the length of the arrow shows the magnitude of the values, the size of the value. So the direction of the arrow is the direction that it's acting in, and the length is equal to magnitude. See if I can fit that in. No, just off. Okay, length equals magnitude. Now, if I show you two vectors that we're hoping to add together that are perpendicular, we've got a vector acting in the vertical dimension and a vector acting in the horizontal dimension. Now, to add vectors together, you simply place them end to end. So these two vectors result in something that looks a little bit like this. So we've got our first vector, then at the end of that arrow we place our next vector. Okay, I'm just guessing sizes here, by the way, I'm not measuring them. If you were to do this on paper, you would certainly measure the length of these arrows. So for example, let's say that this arrow was 3 centimeters, because the vector value is 3 newtons, for example. And let's say that this arrow is another 3 centimeters, because they look about the same size, representing another 3 newtons. And we want to know what the outcome of these two vectors will be. So the outcome vector is simply the direction and the distance between the two initial vectors. So our outcome vector is here. Okay. So this is our outcome vector, and we can do this. We can calculate this one of two ways. We can either draw this on paper and simply measure the length of this vector using a ruler, or we can answer this mathematically. And you might have spotted already how we're going to do that. If you haven't, I'll just give you a small clue by drawing this here. Now, imagine you're back in math class. We are, of course, going to use Pythagoras' theorem, which, if you've forgotten, is x squared plus y squared equal to z squared, with z squared being the hypotenuse, which is the value that we're looking for. So 3 squared plus 3 squared is equal to our unknown squared, which gives us 9 plus 9, the root of, gives us z. So we've got square root of 18 is equal to our unknown, which gives us about 4.24 newtons. Okay, so we've calculated our magnitude, but now we also need to calculate our direction, which will be the angle here. Now, again, imagine you're in math class. We can, of course, use SOHCAHTOA, and seeing as it is the value of the opposite and the adjacent that we know, we will be using TOA. So we know that tan theta is equal to our opposite divided by the length of our adjacent. So we know that theta is equal to the inverse of tan, 1. And as we'd expect with a opposite and adjacent of equal length, we have a angle of 45 degrees. So we now know that we have a force of, let's change the ink colour, but a force of 4.24 newtons acting at 45 degrees. Okay, so we have our full vector quantity calculated there.